Since p of x is a quadratic, it can be factored as x minus r and x minus s. So when p of x is equal to 0, we have x equals r or x equals s are the solutions. So when p of x is equal to 0, we have p of x is equal to r or p of x is equal to s. The four solutions for this come from the set of 3 and 4 and 2 unknowns. And since p is a quadratic, two solutions are going to satisfy our first equation and two solutions are going to satisfy the second. If we graph this parabola, we might find, for example, that the roots 3 and 4 will produce a value of either r or s, and our two unknowns a and b will produce another value. Or, for example, we could have 3 and a, one of our unknowns, produce r or s, and then 4 and our other unknown b produce s. So we're going to divide this into two cases. One is that p of 3 is equal to p of 4, and then p applied to our two unknowns also gives us the same value. Our second option is that p of 3 gives us the same value of p of one of our unknowns, and p of 4 will be the same as p of our other unknown. Let's start with case 1. We'll find p of 3 in terms of r and s by plugging in for x, and expand and combine like terms. Here's our expression for p of 4. These two expressions are equal to each other, so we'll combine like terms and simplify. And r plus s is equal to 7, and we also need to have p of a is equal to p of b, so we'll plug in for a and b. And we'll expand and simplify. Combine like terms and factor on the right hand side. We're given in the problem statement that a and b are distinct, so we can divide by a minus b. So a plus b is equal to r plus s, which we have from before as equal to 7. So our first value of the square of a plus b is 49. Now let's go on to case 2. And we'll plug in again for 3 and a, expand and simplify, and combine like terms, factoring out the r plus s from a and minus 3. And on the right hand side we have a squared minus 9. Again, all four of our solutions are distinct, so we can divide by a minus 3. And we have this simplified equation. Let's plug in our second pair and expand, combine these terms by factoring r plus s, and we have b minus 4, and we'll divide by b minus 4. And we have another expression for r plus s. So we have p of 3 and p of 4 are roots of p, then p of 3 is equal to 0, and p of 3 is going to be equal to one of our roots. And similarly with p of 4 is going to be our other root. So from this first equation, plugging in as before for p of 3, this is equal to r. And from this equation, for p of 4, we plug in, this is equal to s. We can subtract p of 3 from p of 4, and we get 16 minus 9 is 7, and then minus r plus s. And on the right-hand side, we get s minus r. And we'll solve for s, which is 7/2. We can plug that into either of these equations. We'll try this one to solve for r. This gives us r is equal to -3. Backing up, we can solve for a and b using our previous equations. We have a plus 3 is equal to r plus s, which gives us a is equal to -5/2. b plus 4 is also equal to r plus s, which is 1/2, which means b is -7/2. We'll add these two and square it. So our second value of the square of a plus b is 36. The problem asks for the sum of these values, 49 plus 36, and the answer is 85. If you'd like me to solve any other contest problems, please leave them in the comments.